Okay, so I think you'll be happy to learn that this is the start of the last bit of vectors and the last bit of Unit 1. And it is to do with the scalar product of two vectors. Okay, so vectors, we can add them, we can subtract them, and we can multiply them by a scalar, so by a whole number. But vectors can't be multiplied by another vector, not in the traditional sense anyway. It doesn't make any sense because we can't really multiply directions. Yeah, multiplying directions doesn't make any sense at all. Okay, but there's something that we call the scalar product of two vectors. Okay, so the scalar product of two vectors is what we're going to be looking at, and it's those two formulas, but don't worry about them too much at the moment. Okay, so the scalar product of two vectors is a quantity. It's a scalar quantity. Okay, so that's what the scalar bit is saying. Okay, and the way that we work this out, the other name for it is also the dot product. So it's either the scalar or the dot product, because if you look at those formulas, you can see there's a dot in between them, so it's the dot, and it's a product because we're kind of multiplying bits and pieces. Okay, and the way that this is found is it's by finding, it involves multiplying the magnitudes of the two vectors and the cosine of the angle in between them. Okay, so that's the very first one there that I've got, and these are going to be on every slide for every video until we're done with the scalar product. These are on your formula sheet. Okay, so they're on the formula sheet. So they aren't something you need to remember, but it's good if you do. Okay, but it's not essential that you remember them. Okay, and like I was saying, the scalar product is a scalar quantity, so it's just a number, it's not a vector. Okay, so if we have two vectors, say we've got vector A and vector B. Okay, what this is for A, the scalar product of those two, so A dot B, or the dot product, we find the magnitude of A, we multiply it by the magnitude of B, and then the cosine of the theta, which is the angle in between them. Okay, but it's the angle between them when they're pointing out from the same point, right? So because this is the point where they meet, and they're both pointing away from that angle is fine. But if we've got two vectors that are like we were doing a vector product, like this, so if that was A and that was B, and then we've got some angle in here which let's call x degrees, okay? The actual theta we need to do is we need to rearrange the vectors so that they are not nose to tail anymore. Like when we're adding them, they need to be nose to tail, so like following in a line. But when we're doing the scalar product and finding the angle, it needs to be the opposite, so they need to be both going out from a point, so we can kind of rearrange them. And the theta would be that angle in there, because they both have to be going out from the same point. Okay? Right, so let's do some examples with, or an example of this first. So, if we have, say this one here, we'll use the A and B one. We're going to find the scalar product, so we're going to find A, B. And we're going to say that this length, the length of A, so the magnitude of A, we're going to give it a value and it's going to be 3. The magnitude of B is going to be 5. And that angle is 27 degrees. Okay, so it's just using the formula, so it's the magnitude of A times the magnitude of B times the cos of the angle. Okay, so it's 3 times 5 times the cos of 27. This time, because it's the cos of 27, that's not a number that we know automatically. You can get exact values here, okay? The exact values, I promise, they're never going to go away. They're going to keep haunting us forever. Okay, so you can't forget about them. You can't pretend that you don't know them. You need to learn them. Okay, so, and then when we put that into our calculator, we get 13.365 or 13.37 with 2 decimal places. Okay, so that is a scalar product. It's a formula that we need to know. Okay, that's the first one. Right, so a little bit of an introduction into the second part. I'm not going to show you the big proof of where that comes from. You can find it by looking in the Lecky and Lecky textbook on page 118 if you want, but it's very long-winded and you get given the formula, so you don't need to know the proof at this point. Okay, so you can find the scalar product using that second formula as well, and we're going to do that in a second. Okay, so our second formula is we've got A dot B, or the dot product of A and B is A1 B1 plus A2 B2 plus A3 B3. Okay, so you use this version when you've been given the vectors in kind of column form or in unit vector form. So instead of being told the magnitude, you get told the components of the vector. Okay, so it's just saying that like A1 is the x component of that vector, A2 is the y component of that vector, and A3 is the z component of that vector. Okay, and the same goes for B. So B1 is the x component, B2 is the y component, and B3 is the z component. So if we have that A is 7 to minus 3, and we've got that B is equal to minus 2, 11, 4. Okay, we can find the scalar product or the dot product. A dot B is equal to, it's A1 B1 plus A2 B2 plus A3 B3. Okay, it might seem like a bit of a chore, but we have to write out the formula every time. So A1 is 7, so we get 7 times minus 2, plus A2 is 2, B2 is 11, and then we've got to add A3, which is minus 3, times B3, which is 4. So we're multiplying the x components, the y components, and the z components, and then adding them together. So we've got 7 times minus 2, which is minus 14, plus 2 times 11, which is 22, and then we've got to plus minus 3 times 4, which is minus 12. Okay, so we have 14 plus 22, take away 12, which is minus 4. Okay, so the scalar product or the dot product of those two vectors is minus 4. Okay, so to start with, that is everything we need to know about the scalar product, but we will go further in the next videos. But that's just the brief introduction to those two formulae.